Welcome to Kansas State. My favorite part of going to any section meeting is visiting other people's glass blowing shops. Not always the demos, but seeing how they do things, what special tools they have that might make my job easier, or what techniques they use that would make a job faster for me. So I want to share some things with you that I'd have to say none of them are original with me. I probably got the idea for some of these things from some of you, so I hope there'll be something that's useful for you today. So at any rate, we're glad you're here. When I came to Kansas State University for a couple of summers to work, Mr. Ono had this little paddle, pretty simple little graphite paddle, not a real long handle, with a little V cut in the top. That makes it nice. It's like a pair of support rollers, or a set of support rollers, except now you have graphite and you can, it's like infinitely adjustable support rollers. You can be right where you want in the flame, holding it whatever angle you need to. You can move in and out, back and forth, up and down. Super useful little tool, and any paddle can be turned into something like this just by filing a little V across the top. That's a super useful tool, and you can get very close to the flame. You know, some people use their fingers to support their glass. This is obviously a lot closer and a lot safer. Straightening rollers, or alternatively called tooling rollers, are something I definitely couldn't get along without on my bench. These were from Glasscraft quite a while back. I'm not sure they are available anymore, but they have nice big wheels that spin freely on these shafts, and it's easy to rotate glass. You can use them to flare the end of a piece of tubing if you have it set up where your torch can hit the end. It's easy to tell if something is straight or not, if it's coaxial through its length. I don't know if you can see this very well, but a lot of times one stopcock arm will seem to run very true, while the other one will give a little bit of wobble. So if you're going to use it in your lathe, if you're going to chuck it up and your lathe runs true, you'd like to hold the end that's going to make the end you're going to seal run the most true, run the most accurately. I use them to check out standard taper joints if I'm going to be sealing a joint in a coaxial fashion. It's nice to pick the ones that run the most true, that run the most coaxial. And since you grip on the outside of a piece of tubing, it's good to know what's going to run the most accurately or the most coaxial for you. Sometimes these are way off. If they are, I'll use those for side neck, something that doesn't need to spin completely accurately. If I find a super nice one that runs really smooth, I'll usually write holder on it and set that one aside to use as a holder in the future. First thing I'd like to share with you is this Carvers vise. It's from Lee Valley. It's a Canadian company, and it's made by Veritas. It's kind of a branch of Lee Valley. It's very useful because you can position it in almost any position you want, which if you're carving a block of wood, it's handy, but it's also handy working on manifolds. The parts holding the manifold are not wood, they're garolite or bakelite is what a lot of people refer to that commonly as. It's kind of an epoxy resin. It's not completely heat resistant, but it's very stable. You can machine it. Very useful for making clamps and things like that. I learned about this Carver's vise from George Kopp at the University of it was in Montreal, I'm not sure of the university. The nice thing about this is you can orient your manifold in any position you want to make your seals easier. A lot of times I'll use the straight line below the window to line things up with. That way any 90 degree to that, like the vertical of the window, makes it easy to get things lined up very nicely. You can see the handle there is a pull and release handle. I'll go do that so you can kind of see how that thing pivots. So I can go perfectly 90 degrees up and down, whatever position you want. So from this position, it's pretty easy to line things up. I have numerous vertical seams and edges of windows and floor tile. You can find 90-degree angles everywhere in a glass shop, and I use those to make sure everything is lined up nicely. You can use the front edge of the bench to line things up. A nice thing about this is you can see that this torch here is a little bit in the way, but this just has a wing nut underneath and a stand so you can move it to any position you want to. I have another hole over here near the edge of the bench where it can also be mounted where it's a little bit more out of the way, but people are a little more likely to walk into it when they walk in the doors. So I usually have it sitting in this position, or I can take it off completely if I'm working with something on the bench. George had a different setup on his. It was pretty nice. I haven't gone that far with mine, and that is he made it so it had a grip handle here so he could take it off and work with it while he was holding it in his hand. That way you can really get things around, get the glass to flow the way you want it to. So all in all, it's a very versatile tool. They're around $150, so if you make very many manifolds, I think you'd see that it paid for itself pretty quickly. In my experience, when you use a ground glass joint as a holder, either one of two things will happen. Either the joints you're sealing on will fall off at the most inopportune time, or you won't be able to get them apart when you need to. That's easily alleviated by putting something in between the two ground glass joints. It needs to be thin. Sometimes you can use a strip of graphite tape that goes all the way around to lock them together and then allow you to separate them. This is something I learned from Barry Lafleur a long time ago, a past ASGS president. This is glass cloth electrical tape. It's kind of has pretty good sticky stuff on it, but we're not interested in the sticky part. We're interested in what's left after you run it through the oven, and that's this very thin piece of glass cloth. So just by putting a little piece of that between your two joints when you stick them together, they're held securely. The glass cloth tape isn't thick enough to really offset how well it runs. Doesn't make its concentricity any worse, and they're easy to separate when you're done. The glass cloth is pretty fragile. It doesn't last more than a time or two, but you can cut a 12-inch strip, run it through your oven at night when you anneal your glassware for the day, and then cut it into little pieces the next day, and those will probably last you for a few weeks or a month. So a lot of times you want repeatability in a job. You don't need to get a protractor out to measure everything. You can just cut a piece of sheet metal. This is a 105/75. Those are the standard angles you see on a lot of glassware. I've got plenty of these, as you can see. Most of them are 105/75. Sometimes a 90 with a notch cut out in the corner so you can get it right in on your glass without it being affected by the seal area. Some specialty jobs, here's a 55-degree angle, an 85, an 82. The problem is when you've been glass blowing for so many years, you forget what all your jigs and fixtures were for. So I don't remember what those angles were for, but they were pretty handy to me at some time. Things I hope you found useful. If you saw anything that piqued your interest, please ask any questions you might have. I'd be glad to share with you. I hope you had a good time visiting K-State, and if you're ever in Manhattan, Kansas, I hope you'll stop by, visit the glass shop. It'd be nice to see some people.